Okay, so acids and bases, question 7. This is the scary stoichiometry, and with physics and chemistry, what we need to do is label the numbers. So this is a mass, it's little m. This will give you the molar mass, sodium carbonate, Na2CO3, and 0.7 decimeters cubed, that is a volume. So they want you to calculate the concentration, which is C, and they give you an M and a V. So we just use this formula. So you want C, you were given M and you were given V, and you can work out molar mass. The molar mass of sodium carbonate is 106, because that is Na times 2 plus carbon plus oxygen times 3. So it's 23 times 2, 12, and 16 times 3. Then it asks for the pH of the solution be greater than or less than 7. So that is unfortunately the hydrolysis thing, which we did a million times. I don't know whether you remember, but we take the Na2CO3 and we cut it in half, and we get Na plus and CO3 2 minus. And like we did in class, I don't know whether you remember, but I do remember doing it. HCl, H2SO4, and HNO3. Those are the strong acids. Are any of those here? No. Then that means that this bad boy over here is from a weak acid, because the negative half is from the acid, because the acid donates H+. So the acid gets rid of H+ and becomes negative. That is the weak acid half. This is therefore a strong base. If you know that it's a weak acid and a strong base, you can know that it's greater than 7. But what you need to do in order with the equation to show that that's what happens is you need to react the weak half with water. So CO3 2 minus plus water makes HCO3 minus plus OH minus. Otherwise, you can have, it's balanced, because the H2O is H plus and OH minus. That's the two halves of H2O. And because this thing is negative, it bonds with the positive half of the water to make HCO3 minus and OH minus. So let's see what they did. Same but different. So they said greater than, which what I said as well. And then you add water to it. So that's exactly what I just said we do. So because you made OH minus, it's a base. So we did do this in class a couple of times. Then 7.1.4, they say the sodium carbonate solution, which we now has a pH of greater than 7, so it's a base, is titrated with dilute hydrochloric acid. So we know that the sodium carbonate is a base, and we know that hydrochloric acid is a strong acid, because it's one of our strong acids. So that means we have got a strong acid with a weak base. Sodium carbonate is a weak base. And so that means strong acid, weak base. The pH range should be here for P. It should be P because you reacted a strong acid, which is hydrochloric acid, and a weak base, which is the sodium carbonate. Carbonate is a weak base. So let's see again what they say. P, and the titration of a weak base and a strong acid. So that's what I said. The equivalence point, which is the end point, is a pH lower than 7, because it's a strong acid and a weak base. Then, the last little bit for this one, before we do the 8-mark stoichiometry one, is the definition. There's always a definition, just about, in every question. A dilute acid is an acid that contains a small amount of acid in proportion to the volume of water, and that's 2 or nothing. There's a difference between strong and concentrated. So you get strong and you get concentrated, and you get weak and you get dilute. Concentrated is a small amount of water added. Dilute is a large amount of water added. Strong is it will make a large amount of H plus if you dissolve it in water, Weak is if it'll make a small amount of H plus if you dissolve it in water. It's a different thing. A weak acid can be concentrated or dilute. A strong acid can be concentrated or dilute. It's the same, sorry for the gross example, but pool acid is a strong acid. If you add a lot of water to it, it's still a strong acid. If you add a lot of water to it, it's like in the swimming pool. But a weak acid is vinegar, and it can either have a little bit of water added and be concentrated, or a lot of water added and be dilute. Dilute and concentrated and strong and weak are not exactly the same thing. Okay, so now for the 8-mark scary, 7.2.2, what we do with stoichiometry questions is we label the numbers. So in this case, we have H2SO4 and we have KOH. And it tells us that 0.01 moles of dilute sulfuric acid is mixed with 0.024 moles of potassium hydroxide, and the total volume of the final solution is 0.2 decimeters cubed. And they want you to calculate the pH of the final solution. And that seems crazy because they gave you so few numbers, but we're just going to do what we normally do in terms of stoichiometry. And we got given 0.01 moles of this one, and it got added to 0.024 moles of potassium hydroxide, and the total volume of the final solution is 0.2 decimeters cubed. So what happened was that these two reacted together, and I need to work out which one is in excess. So the ratio of H2SO4 to KOH is 1:2, which means that 0.01 of the acid is going to react with 0.02 of the base, which means that the acid is the limiting reagent. I have more than enough base. I need 0.02 and I have 0.024, which means that the leftover, the excess, that's not how you spell excess, whoopsie. The excess is KOH, and that is equal to 0.024 minus 0.02. So that is 0.004 moles. And the KOH forms K plus and OH minus, and the ratio is 1:1. So we have 0.004 moles of OH minus in the final solution, which has a volume of 0.2. So the concentration of OH minus is 0.004 over 0.2, which is 0.02. Now we have a concentration of OH minus. And what we do with that is we use this formula. OH minus is 10 to the negative 14. Well, sorry, they don't write it like that. It's 1 times 10 to the negative 14. So those two multiplied together gives you 1 times 10 to the negative 14. That one is 0.02. So you can work out the concentration of H3O plus, which makes it 5 times 10 to the negative 13. And then you use the pH formula, and that's H3O plus. And you get minus log 5 times 10 to the negative 13, which is then 12,30, which is a nice answer. It should be basic because KOH was in excess. And basically we use this formula here to convert between base information into acid information. So let's just see where you get the marks for that. See if I can rub this out quickly. So if you just look at the memo, which I put out on the side somewhere here, let me go fetch it quickly. So this is the method I would like us to use, but you can also do whatever else you want to do. And then we get 12.3. So you see, they tell us to tell you to do 2 decimal places, and then they don't do 2 decimal places. But anyway, that's a quite nice thing with 8 marks. But if you can't get the 8 marks, you can at least, and we can all work out this, which would get us 1 mark, and we can work out this, that will get us 3 marks, and maybe even this one. So we can at least maybe get 4 out of 8.